Okay, we are on differential equations. Not just any old type, these are ones that are called separable differential equations. And those are ones where the functions for x and y can be, guess what, separated, and we can write them in a sort of a rational expression, and then by pulling them apart, we can solve them relatively easily. So the trick is to write this as a fraction, I think. Visually, it's the easiest way to picture it, where you've got an x over a y, so it's diagonally opposite the respective dy and dx. So this can be x, and this can be e to the y. And it's the same thing as this algebraically. You need to be good at your algebra a little bit. But now diagonally, I can, in a sense, cross multiply, and I have x then dx is equal to e to the y dy. And then since I've separated the parts, this is like a function of x, and we're considering little bits of x and a function with y and little bits of y. If I integrate these, then it's still equivalent, and I have something I can solve. So integrating this will give me 1/2 x squared, and that's going to be equal to the integral of this, which is just e to the y. And remember, since we're integrating, we have to have a constant, and we can put the constant on either side. There's more room for me to write it here, so I'm going to stick it over here, but typically I think we'll write it with the x because we're really looking for a solution in which y is a function of x. So if I flip that around and I write e to the y equals 1/2 x squared plus c, then I can take the log of both sides, and I'll have that be y then is equal to the ln of 1/2 x squared plus c, like this.